Nanoplastics amplify toxicity of tire chemicals in water tire. For years, micro and nanoplastics have been viewed as more of an aesthetic and environmental nuisance than an active health risk. But recent findings suggest these particles are not just passive debris. In aquatic systems shaped by urban runoff and tire wear, plastic fragments are now acting as delivery vehicles, amplifying the toxicity of chemicals they encounter, rather than dispersing or neutralizing them. A recent study in environmental science and ecotechnology used zebrafish embryos to explore how nanoplastics interact with 6-PPD, a tire additive already under scrutiny for its role in salmon die-offs. The research reveals a striking result. Nanoplastics significantly intensify the toxic effects of 6-PPD, especially in visual systems. Instead of functioning as inert particles, the plastics seem to actively carry pollutants deep into biological tissues, altering where and how chemicals cause damage. Controlled lab tests showed that when zebrafish embryos were exposed to 6-PPD alone, they experienced moderate eye development issues. However, when nanoplastics were introduced alongside the chemical, the impact was far more severe. The plastic particles accumulated in eye tissues, transporting 6-PPD with them and increasing its concentration at the site. This Trojan horse dynamic reframes how plastics function in polluted waters, not as dilute agents, but as toxic delivery mechanisms. Biological consequences, from structural damage to functional impairment. The physiological effects were functional, with co-exposed embryos displaying eye malformations similar to myopia, disorganized retinal layering, and higher rates of cell death in ocular tissues. These abnormalities weren't cosmetic. When subjected to phototaxis tests, which assess vision-based behavior, the fish exhibited significant visual impairment, indicating the damage had real ecological consequences. On a molecular level, the disruption extended across multiple cellular pathways. Gene expression related to phototransduction, oxidative stress, and eye formation was significantly altered. The damage spread beyond the retina to include the lens and blood vessels of the eye, indicating a system-wide breakdown in ocular health. One key mechanism identified was ferroptosis, a form of iron-dependent cell death. The study showed that co-exposure to nanoplastics and 6-PPD overwhelmed antioxidant defenses, causing excess reactive oxygen species, lipid peroxidation, and mitochondrial damage. These are not subtle effects. They signal fundamental cellular failure, triggered by pollutant interactions that current regulations often overlook. For aquatic life, especially species that depend on vision for feeding, predator avoidance, and migration, these changes could have serious population-level consequences. Early developmental impairment can ripple into broader ecosystem instability, with potential long-term impacts on fisheries and biodiversity.